Welcome to the memory management topic. And in last few classes, we learn about the contiguous memory allocation. So in the contiguous memory allocation, what will happen is if we have a process, and let's say a process is of, let's say, 4 KB, and this is, let's say, process P0, and in our main memory, and let's say the main memory is of 4 GB. So this particular process would be allocated in some place like, and this is the size of let's say 4 KB. So contiguous memory will be allocated uh, to the process into the main memory. So this we have seen in the contiguous memory allocation. And definitely this particular process will be there in the secondary memory. So it is residing in somewhere in the secondary memory, and from the secondary memory, this process will be given to the main memory, and from the main memory, the CPU will take this particular process by requesting it. And definitely here also what we required is it is CPU always generate the logical address with that, and logical address is the address of this particular secondary memory, and logical address, or it is also called virtual address. And so this particular address that has been generated will be translated using memory management unit, and this will convert into the physical address, and this physical address we can find from the main memory from here, and we are fetching the data and we are giving into the CPU again. So this is the way how we are doing in the uh, contiguous memory allocation. Now let's talk about something related to the non-contiguous memory allocation and why we require this non-contiguous memory allocation. So the first problem was the internal fragmentation. And the second problem was the external fragmentation. Internal fragmentation are the fragmentation done into the main memory if the some sort of memory is left after putting the process into that particular fixed size memory allocation, and as well as the total internal fragmentation, or let's say we have 4 KB, and let's say another process was there which is having the same size of 4 KB, but we cannot allocate it. Why? Because it is not in continuous fashion. So that is called external fragmentation. Both the fragmentation exist into the non-contiguous memory allocation. So to solve this particular problem, we have the defragmentation, or the concept of compaction. So compaction or defragmentation is the process in which we put together the free spaces, and we put and in that way we'll have the contiguous memory. But the thing is that it is not as advisable for the memory with the higher size, because all the time it is taking a lot of time, and at that particular time CPU will do nothing and will be idle state. So in the non-contiguous memory allocation, to solve the problem of internal and external fragmentation, we have the concept which is called paging. So what happened in this particular concept? The whole process is divided into number of pages. Let's say P0, P1, P2, P3. Let's say we have a process, and this process is divided into number of and this is of same size. So let's say if the process is having 4 KB of size, so this is of 1 KB, this is of 1 KB, this is of 1 KB, and this is of 1 KB of size. And what we do is, in the main memory, we'll put those pages in such a way so that it will be allocated in maybe in different spaces. So the main memory is divided into number of frames, that is called frames, number of frames. And this number of the size of the size of the page will be equal to the size of the frame. Generally we'll do that. Why we do that, I'll let you know. So you assume that we have the frame. This is the frame, let's say frame number 0, 1, 2, 3, 4, 5, 6, 7, 8. So we have number of frames available into the main memory. And we are putting all these pages into the frames which are available. So let's say we have some frames which are available. Let's say here we allocate P0, here we'll allocate P1. Let's say here we'll allocate P3, and here we'll allocate, let's say, P2. So this is the way how we can keep the process into number of pages. So as you can see, this particular process is divided into number of pages, and each page of, we have some size of the page. That size is depend upon operating system to operating system. So it may be anything, and the page size will be equal to the frame size. We assume that. Why we are doing that? The reason is very simple. So if the frame size will be less than the page size, so this page cannot be accommodated into the frame size, right? But if the frame size is more than the page size, so we have the problem of internal fragmentation again. Why? Because the frame size, as I told you, the main memory is divided into number of frames, and number of frame size is the same as the page size, as I told you. So let's say the page size is 1 KB, the frame size is also 1 KB in that way, right? So this is how it will be done. Now, we have some more point that we have to remember. Like we have, let's say